So welcome back. So we are discussing the operators in the VHDL language. What are the different operators are available and how they can be used in the language. So there are different types of operators are available, and that we discussed in last class logical operators, relational operators, and shift operators. So the rest of the operators now I will like to discuss. The rest of the operators like adding operators. Coming to adding operators, the different adding operators here are the adding operators purpose is for addition, subtraction, and concatenation. Okay, adding operators action are the uses of adding operators generally for adding, okay, adding to integers, or addition operation, sum operation, subtraction operation, and concatenation. Concatenation means place side by side like that. Okay, so three different adding operators are available. Those are plus, minus, and ampersand. Okay, plus for addition, minus for subtraction, and the symbol ampersand for concatenation. Okay, they are appending operation. Okay, so see the example on one by one. So that is in the example, okay, only concatenation I think I have represented here. So concatenation operator is ampersand, right? So C ampersand A ampersand T, like that the ampersand is used. Then what is the expected result? Cat, just CAT, cat. That is, it places all the characters side by side. Okay, so that is the uses of the concatenating operator. Similarly, the plus operator for adding the two numbers, minus for subtracting the two numbers. Okay, then multiplying operators. What are the different multiplying operators are available in the language? I think they are also okay, not okay, there are four: asterisk, slash, mod, rem. What for asterisk? For multiplying two numbers, slash for division, mod for modulus operation, rem for knowing the remainder. Okay, so these are the four multiplying operators are available in the language in order to do different operations like multiplication, division, to know the modulus and to know the remainder. And miscellaneous operators case, I think you have two operators. One is absolute, ABS for knowing the absolute value, and double asterisk. Double asterisk is for representing exponent. Okay, so like that, six different logical operators so far we have observed. Logical operators, then shift operators, relational operators, additional operators, multiplying operators, and miscellaneous operators. Okay, now also see one example, a VHDL program for the uses of this. Here one program is available, that is library IEEE. As usual, you know, for every VHDL program, first of all you need to open one library IEEE. So library IEEE, then from that library select one package named as okay, here named as numeric standard.all. Okay, this is the package with all numeric definition. I mean the operators on numeric definitions will be available. Okay, so this is another package from this library. In previous class we observed the standard logic 1164.all. Standard logic 1164, that is the package name, and another package is numeric standard. Okay, so after choosing the library and opening the package, then declaring the entity, okay, or writing the entity. Okay, how can you write? Start with the word entity, then entity name is arithmetic constant is, that is, this is the name operator given or user given for the system. Okay, for this system, now whatever the system here taking as an example, it consists one input port and three output ports as per this declaration. Input port name is num1, just num. it's a 8-bit length it has. Okay, that too it is under signed data type, signed 7 down to 0, signed 7 down to 0. Then 3 outputs, register 1, register 2, register 3, they are also under the same data type sign and with the different sizes, register 1, register 2 with the same size, 7 down to 0, 7 down to 0. Whereas register 3 also data type is signed, but its size is 15 down to 0, 15 down to 0, so that it accepts 16 bits. Okay. Then one more declaration in the same entity represented here, that is constant coefficient. COEF is the user defined name, but it is a constant object. Previously, whatever the objects that is num, register 1, register 2, register 3, they are automatically or by default they can be declared as signal objects. Okay, but now COEF is the constant object, it is a constant. Okay, and it is data type is sign and its size is 7 down to 0 again, so 8-bit data it is. What is the initial data? 0 0 0 0 0 1 0. That means in decimal case decimal equivalent is 2. Okay, so that is the initial data assigned to this constant. Okay, then end architecture and entity name. So 4 signal ports, 1 input port and 3 output ports here declared, and one constant is there, one constant declaration will be shown in this entity declaration. So after that we have the architecture body. Actually the architecture body represents internal logic. So let us observe what will happen in this digital circuit or in this digital circuit, right? So architecture as per the syntax, start with the word architecture name of entity name is, in the first line we have written the statement for the architecture is architecture name is data flow model of entity name is arithmetic constant is, then begin. So then what will happen in the internally? Okay, so first of all it's showing the addition operation, that is usage of plus symbol between input and constant, and the result is loaded in the register 1. Okay, so input number 8-bit number plus constant also 8-bit number, these two are added and the result will be loaded in the same that is in the register 1. And for subtraction what will happen here, it is shown doing the subtraction operation on the input number and constant number, and the result is loaded in the register 2. Whereas in register 3 in addition case and subtraction case almost the same number of bits we can get. That's why the register 1 size and register 2 size is almost equal to the input numbers. Whereas in multiplication case it multiplies the number and coefficient, that is with some constant value the input number is multiplied, So since number having 8 bits and constant also having 8 bits, so in multiplication case the expected bits are 16. That's why the third output, that is register 3, is declared with the size of 16, 15 down to 0, since it holds the data of the multiplication result. Multiplication result will be stored in the register 3, so that its size is double of the input number, whereas in the register 1 case and register 2 case the result of addition, result of subtraction will be loaded respectively, so that the size of the addition result and subtraction result is same as the size of the input numbers. So the size of the register 1 and register 2 are equal to the size of the input numbers. Okay, but in multiplication case more result consists more number of bits, so the result there where you are going to load the multiplication result where we are going to load, that register size should be double of the input. Okay. So then finally end architecture name. So this is the example showing how various operators, like here mainly arithmetic operators, adding operators, not arithmetic, adding and multiplying operators, two adding operators plus minus, and one multiplying operators we have shown one multiplying operator, that is asterisk, between constant and input number. Okay, those that is the usage of these operators. Okay, so like that the what are the different operators are available in the language and how they can be used, that we observed so far. Now I am going to stop this session. In the next class we will see so whatever the next concept is available as per the syllabus, right? Thank you.